Hello my colleagues, welcome back to Softwaring. Today I come back with another ansys tutorial on how can you do a composite ansys by using ansys workbench. So as you see from the project schematic, as the SCP pre-static structural analysis post will be linked to each other, and then we will get the desired results based on SCP post or structural, as a basic static structural part of ansys workbench. So as you know the drill, we try to show you single step by step. So for more clarification, if we open this result of the static structural, it will display like this. So as is from the project 3, then the model part there will be import geometry from the CP pre, and the geometry will be a model section here. There is also the material epoxy carbon movement, and also there is no any connection here. So there are different imported files here. So since we are do a four light circular tube, so this is the first part of the layered part, and it is angular rotation and fiber arrangement are here. The second one, the third, is the fourth one. So this hollow tube is composed of 4 different layers of epoxy carbon woven. So after that, from the static structural, we can apply the fixed support at one end and the force on the other end. So the total formation will be our final result. So to see in detail, here is our hollow tube. So this hollow tube is composed of 4 fiber arrangement, as I told you before. So this is how display the result and some boundary conditions. And then besides this, you can see the results by using HTTP post. So in this video I'm gonna show you how can you do this step by step. Keep watching. I come back after the break. So to start with our analysis, let us drag the SCP pre into the project schematic. So it will look like this, and then let us check our engineering data first. So from engineering data sources, let us select our composite material. So from the data source, let us select the composite material. So under the contents of composite material, there are different lists of composite materials. So for the time now, let us select epoxy carbon woven, which is last it is 230 gigapascal. And then let us proceed to the next step, which is geometry. So on the CP pre-design module, let us check our unit first. So let us select meter as a unit, and let us start our sketch. Let us select a circle here. And then let us dimension it as usual. So it is radius is 10 meter. I mean 5 meter. And then let us extrude this as a depth 5 meter, and so let us generate this one. And then let us make it a thin surface. So let us select this face, and its dimension, its thickness will be 0 for the time now, and we will update later. And we finished on the design modular of SCP pre. So let us close it and proceed to the model the model of the ACP pre. Once the mechanical ACP pre is open, let us select the thickness of this surface body as this meter, 0.01 meter, and then from the material list there are epoxy carbon woven and structural steel. So let us generate the default mesh for the time now. And, let us close the model part, and then let us update this one. So let us double click on the setup. The ACP pre will do something in the block process. We don't know that. We don't need to know that. And after this process, it will open this like this. So this is ACP pre ACP. This is ansys composite pre-post. So from the model of the ACP model, and also there is material data. So from the material data, let us expand the tree, and as you see from here, there are two materials, structures and epoxy carbon woven. So let us create a new fabric here. This means the arrangement of materials on the cross section of the cylinder. So the material is epoxy woven, and its thickness will be 0.02 millimeter, and the area is not needed. So let us see some detail analysis. So let us apply this one. So this is how can it distributed on the polar property. So you do not need to know this the first time. No, this is introductory. Just create a fabric and then proceed to the next step. So after that, let us start to create some stake ups. So the stake ups will be let us select fabric. Let us select fabric here. Fabric here. So this composite material is composed of 4 layers. So let us make it 45-degree fiber arrangement, and this one is minus 45-degree, and the last one will be 90 degrees. So this material is composed of 4 layers with different fiber arrangement. Since this is a single material, epoxy carbon woven, so it has different layers by its layers differ by fiber arrangement. So let us accept this one. Before that, let us check some on the analysis part. Let us check those boxes, and you will see how they are arranged, the different the 4 layered material. So let us apply this one. So this is how can they arrange it from the inner to the outer surface of the seal, the tube. So the thickness and the fiber arrangement will be here. So no, you don't need to know this very well. So it's introductory, just enough to create a stick up only. After that, there are element set here. So all elements are needed for this requirement. And then let us create rosettes. Rosettes means they are basically they are necessary for the direction of fiber arrangement. So let us accept the default mesh for this time now. And if you click on here, we do not see anything. Let us skip for the time now, and then from oriented selection set, let us create this one. So element is all elements here, and some pointers at this point is necessary for this analysis, and the results will be we created before. So as is, let us update this to, and then if you click here, this is how the four fiber arrangements are, the four layers are arranged from inward to outward direction. And then let us create a model group. So let's accept this one, and then from here let us create ply, and then the intersection would be, or section 1, the ply material is take up, and then let us accept other settings as a default, and then let us render this one. And also we can create some solid elements, solid model, and let us accept this one as usual, and let us accept as it is. So we finished what we have to do on the SP composite pre-post part, and then let us update this setup. Let us drag the static structural to this one, and then let us drag this result, the setup of the SP3 to the model of the static structural. Let us transfer the shared composite data, and then let us refresh this model step of static structural. The static structural mechanical enterprise pre-posted open like this. So in this part we just check the imported files here. So if you want to see the 4 layers of this composite material, we can expand the imported file tree. So if you want to see some detail, if you zoom this out, anyways, those are the 5 arrangements, but they vary by the fiber arrangement or angle. So let us proceed to the next step. We will see the fiber arrangement later. So from static structural, let us select the fixer support, and let us hold edge selector here. So let us select this edge and make fixed, and then let us select a force, and then let us apply this force at the edge of the other end. So let us select this edge, and also this force is defined by a component. So in the z direction the magnitude will be 1.7 Newton. And then from the solution stage let us insert the total deformation only. So let us solve this one. Yeah, once the solution is done, let us check the scale of the result. So this is the deformation of this two cylinder under the given loading condition. So the maximum deflection would be around 0.48 millimeter at the side of the load. And also let us proceed to the next step. If you want to see the result by using SCP post, let us drag the SCP post here. Yeah, let us drag the SCP post into the model of the SCP pre. And then let us link the solution, the result of the static structural into the solution of the static structural into the result of the SCP. And then let us update some and then refresh stages. When we link it, the SCP post will do something in the black box. We do not need to know for this time now. and then let us open the result of the SCP post. I'll double click on the results. The SCP post will be open like this, so it will do something on the black box. Yeah, so the SCP this is composite pre-post SCP post will open like this. So was the one thing need from these stages from the solution solutions. Let us right click and then let us correct the deformation if you want to know the deformation. Then let us say okay, and then let us update this one. Yeah, so the result will be like this. Basically it shows from the inner side. So the deformation will be 0.00 or 0.48 millimeter, like we get on the static structural part, the solution of static structural part before. So let us see if you want to see other results like total stress, strain, failure, current temperature, progressive damage, and others. You can extract the results by using this stage. So this how can you do a composite analysis by using a workbench like SCP pre, SCP post, and by combining the two with the static structural part. So this how can you do the results. So if you want to see the animated result of the total deformation of the static structure, it will be open like this. So how can you do how can you do composite analysis by using ansys workbench. So thanks for watching my video. If you get this interesting for you, please subscribe my channel. And the next video I'm gonna show you some advanced composite analysis using ansys workbench. That means the fiber arrangement will not vary only by fiber arrangements, it will vary different materials. So I'm gonna show you different consecutive lectures on composite analysis for the time now. Thanks for watching. See you later.